let us see how inspiration and expiration occurs during the normal conditions. You know, first of all, what is inspiration? Tell me. Inspiration means inhaling the air into the lungs. Expiration means exhalation. Exhalation means releasing the air out from the lungs is called expiration. So, inspiration and expiration under normal conditions, how it is happening and what are the muscles responsible for this particular action, how the space is provided in the lungs, how lungs are going to release the gas out from the thoracic cavity, we will discuss in this question. Okay. So, now first we will see inspiration. Inspiration means inhalation of air into the lungs. So, because of that, you see this diagram carefully. So, this is the diagram all about ribs. Okay, what are these? Ribs. Okay, these are all about ribs. And another one is there, diaphragm. What is this? What is this curved structure? This is called diaphragm. So, these two are very important, ribs and diaphragm. You know, diaphragm is a dome shaped muscular structure which is separating the thoracic cavity and abdomen cavity. In this thoracic cavity, this is upper thoracic region and lower abdomen region are separated by diaphragm. So, like that, ribs and diaphragm are very important, especially in the respiratory movements. So, here you see, this is external intercostal muscles. The muscles which are present between the ribs are called external intercostal muscles. External intercostal muscles. And the muscles which are present in the diaphragm are called phrenic muscles. What are these? Phrenic muscles. So, external intercostal muscles and phrenic muscles are present here in this topic especially. So, external intercostal muscles are contracted. What happened? External intercostal muscles are contracted. Once they are contracted, you see my hands position. So, these are the ribs. Suddenly, they are get elevated. So, because of this, the ribs position is slightly forwarded, so automatically some space is provided. See, before that the space is not there. Due to the contraction of external intercostal muscles, space is provided dorsoventrally. And next point you can see, same like that, the muscles in the diaphragm called phrenic muscles are also contracted. So, because of this contraction, you know, just I told it is a dome shaped and it will become flat. It is a dome shaped structure and suddenly it will become flat. So, that's why this dome shaped structure, you see the diagram carefully, it became flat. So, automatically you can see space is provided or not? Yes, the space is provided anterior-posteriorly. Here also space is provided anterior-posteriorly. So, because of that, thoracic cavity increases. So, here the space is increased dorsoventrally and here also anterior-posteriorly space is increased. So, automatically thoracic cavity expanded. Because of these, negative pressure created in the thoracic cavity. Which pressure is created? Negative pressure is created in the thoracic cavity. So, automatically when the pressure is less in the thoracic cavity, automatically from the nostrils, you see, from the nostrils, automatically the air is going to get into lungs. So, here in this you can see the most important muscles, here they are contracted, here also they are contracted, you see the stars. So, like that, contraction, contraction. So, because of that, energy is needed. So, that's why inspiration is a active process. Inspiration is a active process. Let us see the expiration. Let us see the expiration in the same question. You see, expiration means releasing air out from the lungs. So this is called expiration. In this expiration process, what happens we will see now. Generally, just now I told about the ribs elevation. See, because of the contraction of external intercostal muscles, ribs are elevated, right? And also because of the contraction of diaphragm is in flat. So this is the position you are observing in the inspiration. But now in the expiration, what happens? In the expiration, it should come down. Whatever the elevated thoracic cavity and whatever the flat diaphragm is there, they should come back to their original positions. Why? Because you know diaphragm is dome shaped, but now it is in flat. It should come to its original dome shape. As well as the thoracic cavity is also come down to rest. So because of that, what happens? Before whatever the muscles are contracted, that muscles comes to relaxed position. Means external intercostal muscles are relaxed. So because of relaxation, thoracic cavity comes down. And at the same time, you know these, what are the muscles in the diaphragm? Phrenic muscles. So these phrenic muscles also gets relaxed. So because of that, again the force will come. So the force is coming from the posterior to anterior and also from ventral to dorsal. Because of that, pressure from here, here the positive pressure is created. What is this? Positive pressure is created. Because of that positive pressure, when comparing with the environment, so when comparing the environment in the thoracic cavity, lot of pressure is there. So that's why because of this force, the air will go out through the nostrils. So it is released out. So here you see, you can observe one of the important thing that here I wrote relax, here I wrote relax. So for the relaxation purpose, there is no need of energy. So that's why it is a passive process. That's why it is a passive process. So no need of energy for. Okay, here there is a diagrammatical question for, okay, especially for 4 marks compulsory you can expect one diagrammatical question in every, okay, examination. So that's why here, okay, we are now going to discuss about the question, that is VS of kidney diagram. VS means vertical section of the kidney. So in this vertical section you can see kidneys are bean shaped structures. So that's why you have to draw the bean shape. Then, okay, you see there is a fat, okay, around the cushions like structures you can see around the kidneys. What is this? Fat. This fat is going to give protection from the shocks. So that's why fat is there. And kidneys are protected in a capsule. So you have to mention fat, outside fat, and a cap like outer covering or a helmet like structure you are observing to give protection. What is this? Capsule. It is made with fibrous tissue. So that's why it is called fibrous capsule. Fibrous capsule. And here you can see in this particular area, you can see the notch. Notch means, okay, it is bean shaped structure. So that's why you can see a depth. So in this depth, especially 3 main pipes you are observing. What are the 3 main pipes? Let us see now. So one is useful for entry of blood, one is useful for exit of blood. So that's why, what is entry? This is called renal artery, which is going to give blood into the kidneys. Next one is renal vein, which collects blood from the kidney, which consists more urea. And what is this particular part? This is called ureter. What is this? Ureter. So like that, in the diagram you simply draw the outline. After that, simply you can mention the pyramids. Okay, so almost triangle structures you have to mention. Okay, so many, okay, as much as possible, okay, you can able to put the pyramid like structures. These are called renal pyramids. So many number of renal pyramids are there. This outer part is called cortex, the inner part is called medulla. So in the medulla region, okay, these pyramids are present. In which region? Okay, pyramids are present? Medulla region. What are these? Renal pyramids. Okay, so these pyramids, where they are going to open? These pyramids are going to open into cup-like structures called calyces. What are these? Calyces. What are these? Calyces, called cup-like structures. So like this, all cup-like structures are calyces opens into pelvis. What is the center part? Pelvis. What is the cup-like structure which is holding the triangle pyramid? This is all about, okay, calyx. So I am writing here calyx. Okay, and the tip of the pyramid. You see this part, you see I am putting some, okay, lines, minute small lines you are observing. These are particularly, these are called renal papillae. Okay, so like that you have to mention, okay, fat, capsule, cortex, renal pyramid, okay, medulla region, calyx, okay, and also renal papillae. Center part is pelvis. Pelvis extends as ureter. And one more important point is there. Between the pyramids, you observe this between pyramids. You see this. Cortex is invaginated between the pyramids. See, this is outer part. Outer part is extended between the pyramids. Yes, this outer part extended between the pyramids or not? Yes, this extension is called columns of Bertini. Columns of Bertini. So like that, these are the labelings you have to do. At least 6 labelings are essential for a 4 marks question, and this type of diagram you have to draw neatly. Right students, now we are going to discuss about the question number 13, that is synaptic transmission. So in the nervous system, so how a neuron can able to send signal to another neuron, that's what we are discussing in this particular topic. This is all about synaptic transmission. So in the synaptic transmission, first of all we will see what is a synapse. Suppose if you see, this is one neuron, okay, this neuron ends with what is this particular part? So this neuron ends with axon. These are called axon terminals. And what about this particular part? This is another neuron. So like that, one neuron is going to get connection with another neuron. In this, there is a space. This space is called chemical synapse. What is this? This particular space is called chemical synapse. So in this chemical synapse, there will be a liquid which is released called neurotransmitter, which is released from synaptic knobs. What are these? Synaptic knobs. So from the synaptic knobs, neurotransmitter is released. This neurotransmitter is going to get connection with dendrites. So like that, from axon terminals of one particular neuron is going to send signal to another neuron. This process is called synaptic transmission. Especially here we are discussing about the action which is happening in the chemical synapse. So there is a gap. Structurally it is a gap, but functionally it works like a bridge. So that is the important point we have to see here. So what is going to happen in this synaptic knob, we will see clearly. So now I am taking the small bulb. What is the small bulb? Synaptic knob. You see, this is synaptic knob and here you see synaptic knob. So I have just zoomed this particular part. And what are these lines? These lines are nothing but dendrites. These are nothing but dendrites of another neuron. You can also call it is a postsynaptic membrane. What is this? Postsynaptic membrane. And what is this particularly? Presynaptic membrane. Presynaptic membrane. So between postsynaptic membrane and presynaptic membrane there will be a gap. Okay, so here what happens we will see now. Generally when the depolarization is coming, means when the depolarization is coming in this way, means here automatically calcium ions and calcium gates are going to get opened. So because of that calcium ions are going to get jump into the exoplasm. So like that calcium ions jumped into the exoplasm. What they are going to do? In the synaptic knob there will be vesicles. These are called synaptic or neurotransmitter vesicles. So in the synaptic vesicles there is a fluid. What is this fluid? Neurotransmitter. What are these? Neurotransmitter. Okay, so these neurotransmitters okay are present in the synaptic vesicles. Whatever the calcium ions jumped, these calcium ions are pushes these particular vesicles. You see I am drawing here, you see calcium ion. What they are doing? They are simply pushing the vesicles towards the membrane. Before that their location is in the knob, but now they are pushed towards presynaptic membrane. So for that purpose calcium ions are very important. So after that when they reaches the presynaptic membrane, by the process of exocytosis, which process? Exocytosis. By the process of exocytosis, the neurotransmitter is released. What is released? Neurotransmitter is released. These neurotransmitter like a shower. Okay, shower. If from the shower water comes out, no? So like that you are observing a shower of this neurotransmitter is going to get connected with this particular membrane. This membrane consists ligand gated channels. So these ligand gated channels are get depolarized. Because of that sodium channels will open. Sodium activation gates are going to get open. So like that sodium enters into the membrane. So like that depolarization is carried to another neuron. So these neurotransmitters are two types. One is excitatory and another one is inhibitory. So like that excitatory neurotransmitter will depolarize. Excitatory neurotransmitters, what they are doing? They are depolarization. What inhibitory are doing? This hyperpolarization. So because of that depolarization message will send to next neuron. Hyperpolarization will stop the action. So like that depolarization will cause excitation. So you can call EPSP. Inhibitory neurotransmitters generally they cause inhibition. This is called IPSP. At the time of transportation, if EPSP is more, excitation causes, which is useful for the continuation of the message, and hyperpolarization causes IPSPs, so message is going to get stopped. So like that synaptic transmission we discussed now. Okay students, let us see one more type of question. This is going to explain you about the differences particularly. Okay, so comparison type of question. So it is also one of the important pattern during the IPE examinations. So this is pituitary dwarf and thyroid dwarf. So there is the difference between two dwarfs. So what is the difference between these two? Let us see now. Pituitary dwarf, generally hyposecretion of growth hormones. Generally here and there we can see some people, they are very dwarf. Okay, and they are very small. So even though they are adults, but they will not increase their height. They are restricted to 3 to 4 feet like that. So generally regarding that people, growth hormone, that is somatotropin. What is that? Somatotropin is called growth hormone. That hormone is not properly released. That's why it is called hyposecretion. Because of that, what happens in these people? Generally, the epiphyseal line of the long bones becomes epiphyseal plate. What is this? Epiphyseal plate. Epiphyseal line is going to get into epiphyseal plate. So that's why their bones are not properly grow. So that's why they are very short. Even though they are short, their sexual reproduction and as well as their mental ability, intellectuality is perfect like normal people. Only the problem is related to height. Remaining all the activities are normal like a healthy people. So here this condition is also called pituitary midget. Coming to the next category, thyroid dwarf. So generally in the thyroid hormone, which is present in the neck region, hypothyroxine means the thyroxine hormone is little secretion. That is because of hypothyroidism. Especially during the pregnancy condition, in the child who is developing, that is called developing fetus, they will not get proper thyroxine. So that's why this problem will come. That's why this is called congenital disorder. Means the disorder comes from before birth also this disease is there. That's why it is called congenital disorder. Okay, so this congenital disorder is uncurable. So this type of children shows stunted growth, mental retardation. So they are, even though their age is 20-25 years, but they looks like kids and mentally retarded. So their intelligence power is very low. So these type of mentally retarded children we can call cretins. What is the word we will use? Cretins. So this is called cretinism. They have low intelligence, they have abnormal skin, they have deafness. So that's why they cannot hear, so they cannot speak. This condition is called mutism. Deafness is there and mutism is there. So these type of differences you have to read thoroughly for the examination.